Welcome dear student and Jai Swaminarayan. Today I will start your new chapter, chapter number 3, motion in a straight line. Dear student, the basic concept regarding a motion you have studied in the standard 9, right? So basic concept, definition of the motion, different types of the motion and fundamental physical quantities regarding the motion like a speed, velocity, acceleration, that all the things you have studied at the standard 9. So in this chapter we will discuss about the motion in a straight line, or we can say that it is a linear motion, rectilinear motion. First of all, dear student, why we study this chapter, right? Looking around us, walking, cycling, running, right? All the things are in the motion. We look at around the universe. In the universe, all the planets are revolving in a motion, right? Blood circulation in our body. So we can say that everything around us is in the motion. So dear student, first of all, what do you mean by the motion? We will study, and the physical branch of the physics which deals with the study of the motion and the laws of the motion is known as the mechanics. In the first chapter we were discussed about the mechanics, right? What is the mechanics? It is a branch of the physics which deals with the study of the motion of the object and the laws of the motion is known as the mechanics, right? So dear student, in this section of the physics, chapter number 3, chapter number 4, chapter number 5 and chapter number 6 is regarding the mechanics, right? Motion and the laws of the motion. So dear student, let us start with the mechanics, right? What do you mean by the mechanics? Mechanics is a branch of the physics which deals with the study of the motion of the object and the laws of the motion behind the different types of the motion, right? Laws behind the different types of the motion. So mechanics is a branch in which we study the different types of the motion, basic laws behind the different types of the motion, Newton's law of the motion, that all the things we will discuss in this branch of the physics. So mechanics is divided into the two different categories. Mechanics is divided into the two different categories. First one is the kinematics and second one is the dynamics. So dear student, kinematics is a branch of mechanics in which deals with the study of the motion without its causes. We need not worry about a cause behind the motion of the object. Suppose we can say that a bicycle is moving with the speed of the 60 km per hour. But why this bicycle is moving with the speed of the 60 km per hour? Right? The reason behind the motion we cannot study in this branch of the mechanics. So kinematics is a branch of the mechanics in which we study the motion of the object. We deals with the study of the motion of the object without its causes, right? Without its reason. So what we study in the kinematic branch? So kinematic, in the kinematic branch we define the basic physical quantities regarding a motion like a path length, displacement, speed, velocity, acceleration, that all the things, basic physical quantities regarding the motion of the object we will study in this kinematic branch. Meanwhile, dynamics. What is the dynamics? So dynamics is a branch of the mechanics which deals with the study of the motion with its causes and the internal property of the object, right? So dynamics is a branch in which we study the basic reason behind the motion. What is the fundamental reason behind the motion? You know, force is the fundamental reason behind the motion. So in the dynamics we study about a force, right? Laws of the motion, that all the things we study in the branch dynamics. And dear student, kinematics and the dynamics are combinedly known as the mechanics, right? So the combination of the kinematics and the dynamics is called the mechanics. So dear student, understand why we study the mechanics to study the motion of the object, different types of the motion, laws of the motion. We study the branch of the physics, mechanics. So dear student, let us start with the what do you mean by the motion. There are two physical state of the object. Either the object is at a rest or the object is in the motion. Right? Look at around us, different trees, right? Different buildings on the earth, right? If you look the different trees, different buildings, these all the are, we can say that all the trees and buildings on the earth is a rest or a stationary. Is it stationary or is it in a rest condition? While the earth is rotating about its own axis, right? So all the things on the earth is also rotating about its own axis. So is it in the motion? So some person look at the from the moving bus, right? These all the trees are in the motion. So the motion is a relative concept, right? Rest or motion, there are two physical state of the object, the rest or the motion. So when we can say that the object is at a rest, right? If the object does not change its position with respect to time, if an object does not change its position with respect to time, then the object is said to be at a rest, right? So if the position of the object does not change with the time, we can say that the object is at the rest. Suppose the one book is put on the table, right? So if it doesn't apply any type of the force or any type of other type of the energy, the book is at a rest on the table, right? It is not in the motion. So if the position of the object does not change with the time, we can say that the object is at a rest. Now motion, what do you mean by the motion? Define the motion. So if the object change its position with respect to another object with time, then the object is said to be in the motion. So definition of the motion is that if an object or if an anybody change its position with respect to another object with time, then it is called the motion, right? Then the object is said to be in the motion. But dear student, if we look the trees, buildings on the earth, it will appear for us is a stationary from the earth. But if you think about this, earth is rotating about its own axis, all the trees and building also rotating with the earth rotation. So we can say that it is in the motion. So trees, building, all the things on the earth is in the motion or in the rest condition or stationary. So what we can say that? So here the motion is a relative concept between the observer and the object, right? Who can observe the motion of the object? That is a important thing. So the motion is a relative concept between the observer and the object, right? So that means that the object which is rest for the one person, it is, it can be a motion for the another person at the same time, right? For example, if we are looking at trees and building from the earth, it will be seen a stationary for us. But same things, if you are looking from the moon, it will rotate with the earth rotation. So from where we observe the motion of the object is also important, right? So the motion is a relative concept between the object and the observer, and where the observation take place and in which situation the observation take place, it is also a important, right? So for example, if you are moving with the bus and in front of you a bag is stationary on the seat, in front seat, a bag is a stationary, right? So if you are looking the bag, you will appear as a stationary, but the some person outside the bus looking that bag, the bag is in a motion. So which situation the observer take its observation is called the frame of the reference, and the object which is at a rest in a one frame of the reference can be in the motion in the another frame of the reference at the same time. So dear student, let us understand what is the frame of the reference and the types of the frame of the reference. The place and the situation from the observer take the observation is called the frame of the reference, right? The place and the situation where the observer take its observation is called the frame of the reference. So what are the rules for the taking a frame of the reference? There are no rules for taking a frame of the reference, right? So observe the place and situation from where the observer takes its observation is called the frame of the reference. For example, if the person take the observation from the earth, a stationary earth is considered as a frame of the reference, right? Similarly, if the person is looking the earth from the moon, moon is a frame of the reference. Now if the person takes the observation from the moving train, the moving train is a frame of the reference, right? So we can take any frame of the reference, right? The place and the situation where the observer takes the observation is called the frame of the reference, right? So if you are looking at trees building on the earth, it is at the rest, but if you are looking from the moon, it will be in the motion. So in the first situation, if you are looking at trees buildings on the earth, from the earth is a frame of the reference, but if you are looking from the moon, moon is a frame of the reference. So if we consider the earth is a frame of the reference, all the trees and buildings are a stationary, right? But if you consider the moon as a frame of the reference, right, all the trees and buildings are in the motion. So understand, the object which is at a rest in a one frame of the reference, it will be in the motion for the another frame of the reference. So the object which is at a rest in a one frame of the reference can be in the motion in the another frame of the reference at the same time, right? So dear student, there are two types of the frame of the reference: inertial frame of the reference and non-inertial frame of the reference. More detail about the inertial frame of the reference and non-inertial frame of the reference you will study in the chapter number 5. But inertial frame of the reference, the frame of the reference which obeys the Newton first law is called the inertial frame of the reference, and the frame of the reference which does not obeys the Newton first law is called the non-inertial frame of the reference. So dear student, understand about the frame of the reference and the types of the frame of the reference. The observer, the place and the situation from where the observer take the observation is called the frame of the reference. There are two types of the frame of the reference: inertial frame of the reference and non-inertial frame of the reference. There is no rules for taking a frame of the reference. We can take any frame of the reference, but for the simplicity we take three perpendicular axes as a frame of the reference: x-axis, y-axis and z-axis. So we take three perpendicular axes consider as a frame of the reference: x-axis, y-axis and the z-axis. An intersecting point of the three perpendicular reference is called the origin, or we can say that the reference point, right? So dear student, with the consideration of the three perpendicular axes, x-axis, y-axis and z-axis as a frame of the reference, and the intersecting point of the all the three perpendicular axes is called the origin or the reference point. So for the motion, the frame of the reference is the most important point, right? So for the different frame of the reference, the position of the object will be a different, or the position of the object may be a different. So dear student, how we can identify the position of the object? So look at this point like a object P at this position, right? So if you want to identify the position of this object with the frame of the reference X, Y and Z, we need to find the distance on the x-axis, distance on the y-axis and the position on the z-axis. So if you calculate the position, so calculate the position of this point on the x-axis, or we can say that the distance of the point on the x-axis is called the x coordinate of the point, right? Distance on the y-axis we take as a y coordinate, and distance on the z-axis is called the z coordinate. So in the three dimension, x coordinate, y coordinate and the z coordinate, you know that, right? Coordinate system you will study in the standard 10 also, right? So the if this all the three coordinate does not change with the time, the object is said to be at the rest, right? But if we change the frame of the reference, the coordinates x coordinate, y coordinate and the z coordinate will be changed, right? So for the different frame of the reference, the coordinate will be different and the position of the object is also different. So the if you write the x coordinate, y coordinate and z coordinate, it will be a position of the object with respect to this frame of the reference p, x, y and z, right? So if this all the three coordinate remains same, does not change with the time, we can say that the object is in the rest, right? Object is at a rest or a stationary. But if one or more coordinate changes with the time, the object is in the motion. So dear student, let us understand motion in a 1, 2 or 3 dimension. What do you mean by the one dimensional motion, and what are the example of the one dimensional motion? What do you mean by the two dimensional motion and three dimensional motion? So let us discuss the previous frame of the reference, right? If all the three coordinate does not change with the time, the object is said to be a rest or a stationary, right? So if the coordinates of the object with the one frame of the reference does not change with the time, we can say that the object is rest or stationary with respect to this frame of the reference. But if one or more coordinate changes with the time, the object is said to be a motion. So dear student, when the object is in the motion, it's a x coordinate, y coordinate or z coordinate may be a change with the time, right? So if the coordinates of the object changes with the time, the object is said to be in the motion, right? So what do you mean by the one dimensional motion? So if there is only one coordinate changes with the time, the motion is said to be a one dimensional motion, rectilinear motion or a linear motion, or we can say that the motion in a straight line, right? So if there is only one coordinate changes with the time, the motion is said to be a one dimensional motion, or we can say that the rectilinear motion or a linear motion, or we can say that the motion in a straight line. So for a motion in a straight line, only one coordinate changes with the time, either x, either y or z, right? At the one time there will be a only one coordinate changes with the time, the motion is said to be a one dimensional motion or linear motion or motion in a straight line. So if x coordinate changes with the time, the object moves along the x-axis, right? So if the object is moving along the x-axis, the x coordinate of the object will be changes with the time, whereas y and z coordinate remains constant. But if y coordinate changes with the time, the object moves along the y axis, and z coordinate changes with the time, the object moves along the z axis, right? For example, look at this figure. The reference point is O, right? And at the one time, the object is at a position x1 with respect to reference point O. So after some times, y and z coordinate remains constant. After some times, this x coordinate, the object moves from this point to this point, right? So from x1 distance to the x2 distance. So here the position of the object changes with the time. So we can say that the object is said to be in the motion. But here only the x coordinate changes from the x1 to the x2, right? Y and z coordinate remains constant. So we can say that the object is moves along the x-axis. Similarly, if the y coordinate changes with the time, x and z remains constant, we can say that the object is moves along the y-axis. And if the z coordinate changes with the time, the object is moves along a z-axis. For example, what are the examples of the one dimensional motion? So motion of the train in a straight track, right? So train is moving in a straight track. We can say that there is x coordinate changes with the time. The position of the object changes with the time, and in that the x, only the x coordinate changes with the time. So second example is the motion of the object falling from the height. So if the object are falling from the some height, right, its position is continuously changes with the time. But in this case, the y coordinate changes with the time. So these are the some examples of the one dimensional motion, or we can say that the motion in a straight line motion. What are the other examples? You can write by yourself also. Motion of the vehicles on a straight road is also a example of the one dimensional motion. Motion of the arrows blow from the right. So these are also the examples of the one dimensional motion. So try to identify the one or two more examples regarding a motion, one dimensional motion, or we can say that the motion in a straight line. So now dear student, what is the two dimensional motion? You can easily understand. So what is two dimensional motion? If there are two coordinate changes with the time, right? At the same time, there are two coordinate changes with the time. The motion is said to be a two dimensional motion, or we can say that the motion in a plane. For that, we will study in the chapter number 4. Chapter number 4 is a motion in a plane. So in that, if there are two coordinate, either x and y and z and x, simultaneously two coordinate changes with the time, the motion is said to be a two dimensional motion. So if x and y coordinate changes with the time, the motion is in a xy plane. If the y and z coordinate changes with the time, the motion is in the yz plane. And if z and x coordinate changes with the time, we can say that the motion of the object in a zx plane. So here let us consider that xy plane, x coordinate and the y axis, right? So the object is moving in this xy plane from p1 to p2, right? So at the some time, the object is at a p1, has a coordinate x1 y1. So what do you mean by this coordinate? So object p is at a distance x1 on the x-axis, and object p is at a distance y1 on the y-axis. So the coordinate of the object at a p1 is x1 y1. After some times, both the coordinate x and y will be changed with the time. So after some times, p object goes to p1 to p2. Its a x coordinate changes from x1 to x2, and y coordinate changes from y1 to y2. So the coordinates of the object at a p2 is x2 y2. So here dear student, x and y both the coordinate changes with the time. So we can say that motion of this object is considered as a two-dimensional motion. So if there are two coordinate changes with the time, the motion is said to be a two-dimensional motion, or we can say that the motion in a plane, right? So what are the examples of the two-dimensional motion? The motion of the planets around the sun, motion of the moon around the earth, right? All the type of the revolution motion, we can say that is a two-dimensional motion, right? So the motion of the planets around the sun, motion of the moon around the earth, and all the type of the circular motion are considered as a two-dimensional motion, in that two coordinate changes with the time. Another example is motion of the striker on a carom board, right? There are two coordinate changes with the time, x and y. So these are the example of the two-dimensional motion. Another example of the two-dimensional motion is the projectile motion. The projectile is a one special type of the motion which is the example of the two-dimensional motion, right? We will see in the chapter number 4. Now, what is the three-dimensional motion? You understand easily, right? If all the three coordinate changes with the time, the motion is said to be a three-dimensional motion. So all the three x, y and z coordinate changes with the time, right? The motion is said to be a three-dimensional motion. Suppose we are considering a x, y, z coordinate, x, y and z axis. The object is at a p1, has a coordinate x1, y1 and z1. After some time, the object changes position from p1 to p2. So all the three coordinates, x1 is changes to the x2, the position y1 to the y2 and z1 to z2. So all the coordinates will be changed with the time. The motion is said to be a three-dimensional motion, right? So examples of the three-dimensional motion, motion of the birds in a sky, right, is a three-dimensional motion. Motion of the kite, kite flying on a windy days, right? Motion of the kite is also a three-dimensional motion. So dear student, understand about what do you mean by the one-dimensional motion, what do you mean by the two-dimensional motion, and what do you mean by the three-dimensional motion. Try to identify the motion of one-dimensional, two-dimensional and three-dimensional by yourself, and give a one or two example by yourself of a motion of one-dimensional, two-dimensional and three-dimensional. Here dear student, for this chapter our discussion is limited up to the one dimension, because the name of the chapter is the motion in a straight line, or we can say that the motion in a one dimension. So in this chapter we will discuss the one dimensional motion. So only one coordinate changes with the time, either x or y coordinate changes with the time. So in this chapter we will discuss about motion of the car moving on a straight road, motion of the train moving on a straight track, right? This all the things, or motion of the object falling from the some height. This all the type we will discuss in this chapter later on.